So we talked about translations kind of more in their component form using vectors, which of course have direction and magnitude. But and in that packet kind of gave you what a translation was, but you notice here I have left off the definition of a translation to see if perhaps you could come up with some words. Of course you could look at your packet, but can you come up with words on your own? Does anybody believe that they can come up with words? Yes. A movement of a shape, very good. A movement in any type of, any restrictions on that movement? Yes. Okay, it does have to be a rigid motion, very good. Or what's that other word for that again? Isometry, very good. Okay. Any restrictions at all on this movement? Okay. Anything? I think there should be some restrictions because I can't really rotate it, correct? That would be a rotation, okay? So it's basically a movement, which the person said, of an object, almost word for word there. And it's in one direction, sometimes called a slide. Okay? But I do take all points in that object. Some people think, oh, you just take the vertices. No, you take everything. Okay, it's just normally we're concerned with the vertices of this object because they're kind of the edges, the corners, so that we can work with it. Now, we did do the component form, we did all that other stuff, but actually another way you can do it is reflecting it over parallel lines. Okay? Reflect it over one line, then reflect it over the next one. And you actually get a translation. So for this one, whenever you see, like with respect to lines, M and L or something like that, do them in that order. So it says here, basically we should reflect it over here. So could you agree, like if I pick any point, let's pick an easy one. If I reflect it, that means go directly to that point, hit it at a right angle, and go out the other side, correct? And what if I pick just a different point? Well, let's pick, I don't know, this one this time. Go directly there, and then go out at the same side. That's not much of a right angle, but you get the idea. In other words, that should be the same side as that, correct? Now you can probably, yeah, it has a little dip in it there, sorry about that. But you can see why we then talk about reflections first. You would think that we would talk about translations first. You're just moving it here, moving it there, right? Move it up, down, left, right. Okay, but we do that because it is actually just reflections. Because now if I take this point right here and reflect it again, do you notice how if I just went from here directly to that one, do you see how it's just a translation? All it is I took that one and slid it over that far. Okay, but you do have to reflect it over parallel lines. Okay, so if L and M are parallel, this will work once you do both of them. Okay, so it's just another way to get about that particular translation. Or again, you could use vectors. So let's find the translation image of ABC with respect to lines S and T. So as you read that one, we actually have to reflect it over S first. I would strongly recommend you use a pencil on this particular one in case you make a mistake. So let's first go over line S. So pretend line T is not there, all right? And just do line S. So if this is point B, we have to go directly to line S, correct? And how far was that? How many units? 2. You notice I put it on a coordinate plane here for us so that we can do a little bit better job. And so then I would move it just 2 down there. Do you agree that would be what point then? What would we probably call that? If it's actually just one reflection, it's just one transformation, so we would call that B prime. Agreed? So now let's do the same thing for A. How far is A from there? 1, 2, 3, 4. Are we in agreement? So is that where A prime should be, right where I stopped? No, I have to go out the other side that exact same amount, correct? Off that right angle, right? So I don't stop there. How far was it? 4. So we go 1, 2, 3, 4. So that point ends up there. Do you agree with that? Or did I miss? I think I got it. A prime. And how about C? We'll do the same thing. So how far is that? 5. So go 1, 2, 3, 4, 5. So down there, and that would be what? C prime. And then if we connect it, well, wait a minute, this is a lie. They said it was supposed to be a translation. But I have to reflect it over both of the parallel lines for it to be a translation. Have I reflected over both of them yet? Nope, I've only reflected over which line so far? S. Have I reflected over T yet? No. But what was I really nice about with the points I chose? So I'm going to get rid of some of this stuff so you can see better. Which point was I really nice with? For reflecting over. To reflect over line T, which one's really a B? Where's it go? It stays right there, right? It's on the line, right? So this is B prime, but it's also, well, what do you think we do if it's a next one? Prime prime, right? Or we call it B double prime is normally what we call it. So this is also B double prime. All right. So now where's A got to go? Well, here's A right here. So we go up 1, 2, go back up 1, 2. So it's right there. So that's A double prime. You can see how colored pencils might be helpful for this. Okay? And I can get some out if you'd like them. So now we got to go C. Get that out of the way. So how far we got to go? 1, 2, 3. 1, 2, 3. C double prime. Do you believe that is a translation of the original red one? Yeah. You did it right. It should be. Okay, if yours looks a little weird, perhaps you missed some points. But if you reflect over parallel lines, it's amazing. You get a translation. Which would lead me to the question, what if we did it 3 times? What if we did it 4 times? What would happen? Okay? And perhaps you'll have to investigate those as time goes on. But we'll use technology to do that for us. Okay? Or what if the lines aren't parallel? Then what? Who knows? Okay. So we reflected over S, then we reflected over T, from red to blue. Translation, how would we do that? What did that really do? It moved it, well, horizontal change was 0, correct? What was the overall? Let's put it in component form. What was the overall movement here from red to blue? The overall movement for horizontal change was what? From red to blue. Yes. Horizontal. 0. Very good. From red to blue, did it go left or right at all? No. From red to blue, what did it do for vertical change? It went from 1, 2, 3, it went down 4. So how do we do that? -4. Okay. See, these are all the ways you could talk about it. So there is some vector out there that does that. And look at all those vectors. Once again, they are parallel. And this is where some of you say it starts looking like a 3D object, right? Okay, which it kind of does. Okay. So now let's switch the questions around a little bit. Why don't you go ahead and graph A, B, and C? You don't have to, but it would probably be a good idea. And I'm going to ask you for B prime and C prime. Ooh, interesting. All right. So 4, 2. 1, 2, 3, 4. 1, 2. 0, 6. 1, 2, 3, 4, 5, 6. -2, 2. A, B, C. And apparently there's some B prime and C prime somewhere. I don't know where. But we do know that A prime is at -1, -1. So A prime is right there. Guaranteed. And it does tell us that the image is just a translation of the pre-image. So it's just a translation. It's not a reflection or rotation or anything like that. So how would we be able to figure out B prime and C prime? Well, what would be something that's very beneficial for us to know? Yeah, the people are moving their hands up and down and left and right and everything. Yeah. What do we call it? Well, what does that vector do? Wouldn't that be helpful to find out what it does? Well, let's see what it does to A. So here's point A. Right there. So let's figure out that, the component form. What is it? -5, so 1, 2, 3, 4, 5. Do you agree with the -5 part? I do. And then from there I go 1, 2, 3. Do you agree? Yep. I do. So now what? Oh, now move C and B. Oh, okay, ready? Here's B. 1, 2, 3, 4, 5. And then 1, 2, 3. At this point, do you need to do it on the graph necessarily? Or could you do it by looking at the ordered pairs? You could probably do it looking at the ordered pairs, right? I don't know why I did that in red. But anyways, C is 1, 2, 3, 4, 5. 1, 2, 3. Right there, you think? C prime. Wow. There it is. So what is B prime? What's the ordered pair there? Wow, that's a really bad B prime too. What do you got? -5, -1, 2, 3, 4, 5, 3. Now you can tell it's an ordered pair because it's parentheses now, not those little corner-looking things, little arrows. And then C prime, negative, what is it? 7, is that what it is? Negative 1? Now another interesting question. What is the magnitude of that vector? What is the magnitude? In other words, how much did it move it? And how do we figure it out? Yes, Pythagorean theorem. Okay, because we already know that that much is negative 5. We already know that that's negative 3. So don't we really have wanting to know that? Okay. Another way to do it is the distance formula, but remember the distance formula is just Pythagorean theorem in disguise. That's all it is. So here we go. What's Pythagorean theorem again? A squared plus b squared equals c. How do you know which one's c squared? Has to be the hypotenuse. Which one am I looking for here? The hypotenuse, right? Okay. So we got negative 3. Now you have to be very careful with your calculator, because some of you type in negative 3 squared and it tells you negative 9. That's because you don't put negative 3 in parentheses. If you don't put negative 3 in parentheses, it squares the 3 and slaps a negative on it. It knows order of operations, unfortunately. Negative 3 squared is, I hope you know that's 9. Negative 5 squared, I really hope you know that's 25. And yeah, I had those two guys. We really want to say that that adds to 36, right? Because we know that c squared will give us that perfect square root, right? But it actually adds to, unfortunately, 34 is c squared, square root. So c is the square root of 34, which is really, really close to, has to be really, really close to what number? 6, but a little bit below or above? A little bit below, right? Direction, magnitude. Questions? Now, a real challenge on this particular one would be for me to ask you for the 2 parallel lines I'd have to reflect it over to get there. That would be interesting. So if you're looking for a challenge, go for it. It is achievable. Anything else? All right.